our next unit is all about 3D shapes, these polyhedrons. So, a polyhedron is a three-dimensional figure whose surfaces are polygons. Now, what a polygon is, it's a shape made up of lines, basically, lines and edges, like square, triangle, pentagon, things like that. So, each polygon is called a face. An edge is the segment that joins two faces, and a vertex is the point where three or more edges intersect. You can think about this room as being a polyhedron. So these walls are the faces. The corner that kind of makes a line right here, that's the edge, and the point up there at the top, that's like your vertex. Or if you want to think about a box, face, edges, and then vertices. Does that make sense? Okay. So, Euler's formula says if you take the number of faces and the number of vertices and add them together, that's the same thing as the number of edges plus 2. So make sure that you memorize this formula. F plus D equals E plus 2. And we're going to do some examples of it in just a minute. But before we get to those examples, we are going to talk about the 5 regular polyhedrons. So write down these 5 names. All right, so we have our 5 types of regular polyhedrons. Now on a test or quiz, you might have to name the 5, but you won't have to draw any pictures. Hint, hint. Okay, so regular means that they have all the same side lengths and all the same angle lengths, kind of like equilateral or equal angular. We kind of talked about those before. But our first one is a tetrahedron. It's this shape right here. It has 4 sides. What shape is the sides? Triangle. It's 4 equilateral triangles put together to make a tetrahedron. Next, we have a hexahedron, also known as a cube. It's made up of 6 squares. Very good. And then we have an octahedron, 8 triangles, 8 equilateral triangles. A dodecahedron has 12 pentagonal faces. Pentagons have 5 sides, kind of like a soccer ball. And then we have last, icosahedron, which is made up of 20 triangles. Now, some of you have probably seen the meridian stars, right? Well, or like a star like this, meridian stars. Well, the base of them is an icosahedron. So in order to make a star like this, a meridian star, you have to make an icosahedron out of 20 equilateral triangles. And then you have your 20 points that go on your star to kind of make it. So back when we used to teach geometry, people used to have to make these. Or other things, they could pick a star, a gingerbread house, ornaments, or something of their own choice. But anyway, just FYI, that's how we make them. Questions about these sides? Okay. Write down these 3 problems. All right, so we're going to use Euler's formula to help us figure out the answers to these. What does Euler's formula say? Very good. Faces plus vertices equals edges plus 2. So plug in what you know, solve for what you don't know. This one, we don't know the faces. We know the vertices is 9, and the edges are 15. So F plus 9 equals 15 plus 2. And solve it. So 15 plus 2 is 17. We subtract our 9, so F is 8. So if an object has 15 edges and 9 vertices, it has to have 8 faces. Okay? What if we have something that has 8 faces but now has 12 vertices? Well, plug them in the equation. Faces plus vertices equals edges plus 2. So 8 plus 12 equals E plus 2. What's 8 plus 12? 20 equals E plus 2, so E is 18. Now, sometimes you're given these numbers so that way you can go and find them, but if you're not given numbers but given more of a description, you might want to try to visualize that or look back at things that we had before and see if you can find the same shape or something similar. So this one says a polyhedron with 8 triangular faces. That's an octahedron. If we go back and look at this picture, an octahedron, there it is, had 8 triangular faces, right? They kind of came together. So to make this top part, we have 4 triangles that kind of bend together, and to make the bottom part, we have 4 triangles that bend together. Now what we want to find is the edges. Edges are like what? Points, lines, faces? They're like the lines. We want to find how many lines does it take to make this shape. So how many lines does it take for the top section? 4. There are the 4 triangles that make the top, so when they all fit together, you're going to have 4 lines. So at the bottom, we also have 4 lines, but then we have some around the middle. 4 lines around the middle. So how many do we have total? 12. So the number of edges is 12. So if it gives you a description, think about how are you going to put all that together to make a closed-in, solid, 3-dimensional shape, and then figure out how many are there. You could count, or you could just kind of look at that picture and see. Questions? All right, next we're going to talk about what a cross-section is. Just write down those words. Do not draw those pictures. So a cross section basically is what 2-dimensional shape would you have if you cut this and maybe took out the thinnest slice that you could, or maybe you turned it around so that way you could see it. So imagine we cut this kind of box here, and then we cut out the smallest little slip and we laid it down on a piece of paper. What shape would it look like? It would look like a square. You're right. Square. Totally left off the cue. I don't know what happened. That would look like a square. If you cut something parallel to the base, it's going to be the shape of the base. So if I cut this one, what shape would it look like? A triangle. That's it. So when I ask for cross section, just tell me what shape that it's going to make. Okay? And you don't have to cut just shapes that look like this. You might cut like real things. Like imagine if you cut a potato in half. What shape would it look like? A circle. Good. So let's look at another problem. This is a cross-section problem, but instead of cutting parallel to the bases, we actually cut at a slant. So imagine you cut that cross-section out, but then you lay it flat on a piece of paper. Which one is it going to look like? A, B, C, or D? C is actually the right answer. If we cut it and just looked at the paper, it would look like this, but you have to lay it flat down. So if you lay it flat down, it's going to end up looking more like C. A would work if you cut it this way, and it would be B if you cut it this way. But if we cut it at that slant, imagine we take that slip out and then we lay it flat down on a piece of paper. Now this one is about rotations. So the shape at the right is created by rotating a two-dimensional figure around the axis. So it's just spinning around. Which of the following would create that shape? A, B, C, or D? C is correct. A would only make the top part of it, so if you need that bottom part too, you need both. B, that trapezoid shape wouldn't make a cone shape like that where it meets at a point, and this would make that point at the bottom. So we gotta have a point at the bottom and at the top. Does that make sense? Okay. We had a little activity we were going to do, but since we took some time before lunch to do other things, we're just going to jump straight to homework. So there it is. You should be able to finish it before you leave. It comes from the geometry textbook, and it's already in Google Classroom.